Guys, so we have already factored in this class. Now we're going to look at factoring a little differently. All we factored so far is we factored out greatest common factors, and then at most it left us with a quadratic that we factored some more. Now we're going to do factoring a little differently. Let's look at our first example here. Example number 1, we have x to the 6th minus 14x to the 4th plus 49x squared. What is always step 1 when you're factoring? Take out the greatest common factor, which in this case is what? X squared. So we're going to take out the x squared. Now, we're basically dividing that out. And when you divide, what do you do with the exponents? Subtract them. So it leaves me with x to the 4th, 14x squared, and 49. Now, this is not a quadratic, but we can think of it as being in quadratic form, because I can think of x to the 4th as x squared, can't I? Yeah. And so do you see, this would be like the x squared term, this would be like the x term, and there's my constant. So we will try to factor this further. Now it doesn't always factor further, but let's take a look. If I think of this, x to the 4th, it would become x squared times x squared. Does that make sense? Yeah. Now, what can I multiply to get positive 49 that I can add to get negative 14? Negative 7. Now, if I multiplied this back, do I get that trinomial? Yes, I do. Well, how many of you noticed that was actually a perfect square trinomial to start with? Yes! I'll take one. I did. Oh, more than one. Even better. Okay, so I could have gone straight to this. Squared. Okay, so even though this wasn't a quadratic, it was in quadratic form. So we can look for that. Okay, now example 2 doesn't look like a quadratic or quadratic form. But I do see, right off the bat, a greatest common factor. Which is what?
X to the 5th.
X to the 5th. Let's take it out. Okay, what does that leave me with? X to the 8th? X to the 4th? Okay. It is not a quadratic, but can I think about it in quadratic form? Yes. This is what being squared? X to the 4th. So how can I factor, or will it even factor, this trinomial further?
No. Why could you do x to the 4th there, x to the 4th over there, and then you could do like negative 15 on one side and the 1 on the other side, and just do x squared times x.
Not 15, but 16 and 1. Because negative 16 times 1 is negative 16, and negative 16 plus 1 is the negative 15. Okay.
Oh, okay.
Are we done? No. The answer is almost always no when I ask, are we done? Why are we not done? Because what? Oh, this can become what?
X squared times x squared.
Minus 8 and plus 8.
Not 8, but 4. 4. So x squared plus 4 and x squared minus 4. Are we done?
No.
No.
X.
Okay, so this would become, this one does not factor. A sum of squares does not factor, but a difference of squares does. So this would factor to x minus 2x plus 2. Okay, now this is kind of sloppy looking. I don't like the order of degree here. So I'm going to move it around a little bit. It's not wrong if I leave it like that. It's just not pleasing to the eye.
It's still not pleasing to the eye.
I understand. Okay, now everyone we do will not factor and then surprise us and factor some more and surprise us and factor some more. I just like this one. But all the ones on your homework aren't like this, okay? You might have a couple that have an extra step, but they won't all. Okay, I helped make some of them have an extra step. Huh?
Can you explain one of the steps that we
Which
did?
one?
The one that I thought I knew what I was talking about.
Right here? You thought it was 15?
Can you explain how you got the answer?
Okay, what do you multiply to get negative 16 that you add to get negative 15?
Okay.
So you got to multiply to get the negative 16. Because if we were to distribute back through, this negative 16 comes from multiplying this constant times that constant.
Okay.
Does that help? Okay. Yes?
I'm confused as to why you wrote x to the 4 squared over there. Like, I don't get why you...
I was just making you think, if we look at this leading coefficient, can I think of it as a term being squared? Because if I can think of factoring like we factored the quadratics.
And that's what we did.
Yep.
Okay, so instead of doing like quadratic formula or something?
Right. We're factoring a quadratic form. Yes, ma'am. Okay, this is a difference of squares, which factors to the square root minus the square root and the square root plus the square root. So this factored some more into this. Whenever we have a difference of squares, square root plus, square root minus square root. Okay? All right, now let's look at some that we can look in terms of 4-term grouping. You can think of these this way. Now, this is not a quadratic at all, is it? No. It's a cubic. Does it have a common factor? No. Does not even have a common factor. So I can't even turn it into a quadratic form. So what I'm going to do is I'm going to treat it as a 4-term grouping problem. And the way I do that is I separate it, basically. Let's take those two and then separately look at these two. If I looked at the first two in this group of 4, do the first 2 terms have a common factor? Yes. What is it? Squared. And if I factor out that common factor from the first group, what does it leave me with? Plus 1. 2x plus 1. Now, 4-term grouping only works if what we factored out here is what is left here. So when I look at the second group, the only way I can factor it this way is if I can pull out a common factor from these 2 terms that will leave me with the exact same binomial I got when I factored out of the first 2. Is there anything I can factor out of these last 2 terms that will leave me with 2x plus 1? Negative 36. Okay, now do you see I have 2 terms? I have this one and this. This is this product. This is this product. Do you see that those 2 terms have that binomial in common? I do. And if I pull out that binomial, then I'm going to circle what's left. If I pull this out, I'm left with this, and I'm left with this. So if I factor that out, then it leaves me with an x squared minus 36. Because these 2 have the 2x plus 1 in common, if I pull it out, if I factor it out, then it just leaves me with the x squared minus the 36. Okay, no zoning out right now. Can't zone out right now. Okay, am I done or will this factor further? It'll factor further because the x squared minus 36 factors to x plus 6 and x minus 6. Now I'm completely done. Okay. Let's do one more of these together. And then, after I show you cubics, you have plenty to try on your own. Okay, so here is another 4 term, and I'm going to try to group it. First 2 group together, second 2 group together. This doesn't always work, but it does for this one. Then you have to try something different, or it may not factor at all. Nope. We're going to do those on the graphic, and we'll show you how when we get back from break. All right. Oh, wait a second. Do these have a common factor that needs to come out first?
3x squared
It-
and negative no.
3. Don't they all have a 3 in common? So we can't group just yet. We got to take out that GCF.
4, 1, 8, and 2.
Okay, now I can look at them. Now I've taken out the GCF, which is always step 1. Now I can think of these as 2 different groups. Now, the first 2 terms, do they have a common factor? Yes. What is the common factor?
X squared.
X squared. And what does it leave me with? 4x plus 1. The only way this will work is if there's something I can factor out of the last 2 terms that will leave me with 4x plus 1. Is there any term that I can factor out? Negative 2. Okay, so the 4x plus 1 is what these 2 terms have in common. This is what's left. X squared minus 2.
Wait, but Miss Willoughby, there's already a subtraction sign right there, so what did you... Oh, but that would have made that.
And then the 3 was out in front. Now, this is not a difference of squares, because 2 is not a perfect square, so I'm done. There's nothing else I can do. Yes, ma'am.
Where did you go with the x cubed? Like, that's what I'm saying.
Where did the x cubed go?
Yeah.
Okay, when I pulled out the GCF,
Yeah.
I was left with this x cubed and this x squared here.
Yes.
But when I look at these first 2 terms, what is the common factor for the first 2 terms?
2.
X squared.
Yeah.
And when I take out an x squared, it takes that x cubed down to an x.
Oh, okay. All right.
Now, if I distributed all of this back, it takes me right back to there.
And the plus 1 is the one that was in front of us.
Yeah. Mhm.
All right. Thank you.
All right, last thing we're going to talk about today is how to factor a sum or a difference of cubes. Now, we can only factor a difference of squares, but we can factor both a sum and a difference of cubes. And the pattern is so simple. If we have a cube plus a cube, the first thing we're going to do is we're going to lay out our signs. And if it's a sum, it's going to start with a sum. So it's going to start out with plus. And then it goes minus, plus. If it's a difference of cubes, it's going to start with a difference, subtraction, and then plus, plus. So that's the first thing I always do is I set up the pattern for my signs. Now I don't have to worry about my signs at all. So if it's plus minus plus. If it's minus plus plus. Do you see how both of these just have 1 minus? Okay, only 1 minus. All right, so first of all, we have to have a sum or a difference of cubes to start with. So you're going to ask yourself, what is being cubed? What is being cubed? So what was cubed for my first term? A. What is cubed for my second term? B. So the first term goes here. A. And the second term goes here. B. Then we square the first one. So when I square A, what do I get?
A squared.
A squared. And we do the product of the 2 right here. A and B makes AB. And then we square the second one here. So the second one was B squared. Yes, sir.
Wasn't it usually double the product?
That is something different. That is when we are squaring a binomial. But this is factoring a cubic, a sum of cubes. Okay, on this one, I've got A being cubed and B being cubed, so it's the same process. What's being cubed? A. What's being cubed? B. Square it, product, square it. So let's look at two last examples. First of all, when we have this, we have to go, is this a sum or difference of cubes? So, can I write this as a term being cubed? What is this? 2x. Can I write this as something being cubed? 3. So this is a difference of cubes. So let's set up the pattern for my signs. It's minus, so what goes here?
2x.
Minus, and then plus, plus. You're right, Bethany. No. You were just giving me the first term. So, what was being cubed? 2x. What was being cubed? 3. Square the first one. So I'm squaring 2x. When I square the 2, what do I get? 4. And I square the x, I get x squared. The product of the 2x times 3 is 6x. And then I square the last, or the second term. When I square 3, what do I get? 9. So this is the factored form of this. Those two products, this product is the factored form of that. Okay? Now, this one doesn't look like cubes. I don't see any 3's as exponents. But they are cubes. What's being cubed for this first term? X squared. What's being cubed for the second term? Y to the 4th. Because a power to a power, we multiply. Okay, so now I verified that it is a sum of cubes. Now let's set up the pattern of my signs. For a sum, it is plus, minus, plus. And then I just plug it in. What was my first term? X squared. And the second one? Y to the 4th. Square the first one. What happens when I square x squared? I get x to the 4th. Do the product of the 2. X squared, y to the 4th. Square the last one. Y to the 8th. Okay, now you have plenty of practice, and I'll put my answer key up for you to check.